Hello dear students, in this session let us study the concepts of nature of critical points, finding the nature of critical points for a nonlinear autonomous equations. Okay, in the previous session we have just studied the general equation, that is general autonomous equation. In this session let's solve problem based on those topic. So we have a problem. First one is dx by dt is equal to 1 minus y and dy by dt is equal to x square minus y square. This is my autonomous system of equations. Okay, first I have to find out the critical points for this problem. So how can I find the critical points? First I will consider this f of x comma y is equal to 0 and g of x comma y is equal to 0, right? That means 1 minus y is equal to 0 and x square minus y square is equal to 0. From this y is equal to 1. So if I substitute the value of y here, I will get x square minus 1 is equal to 0. So x is equal to plus or minus 1. Therefore, the critical points are, I'm writing CP, which is nothing but a critical points. Okay, critical points are 1 comma 1 and minus 1 comma 1. These two are my critical points now. So now I have to find out the nature of the critical points and nature of stability. In order to find the stability, I have to find out eigenvalues, right? So now for this critical points, I have to find the eigenvalues. So let us consider this as first critical point. That means case 1, critical point x naught comma y naught is equal to 1 comma 1. So here, since this is a nonlinear differential equation, we will consider, let x is equal to x minus x naught. I will consider capital X is equal to x minus x naught. This is the procedure. Okay, and similarly y is equal to y minus y naught. So now we know the value of x naught as well as y naught. Using this, I can write my x as x is equal to x plus x naught and y is equal to y plus y naught. This is nothing but x is equal to x plus 1 and y is equal to y plus 1. X naught is 1, y naught is 1, right? So now differentiate this two equation with respect to t. That means dx by dt is equal to d capital X by dt and dy by dt is equal to d capital Y by dt. I can write this as dx by dt is equal to dx by dt. From the given system of equation, I know what is dx by dt and I know what is dy by dt. So substitute those values here. This is 1 minus y. This implies y is nothing but capital Y plus 1. Substitute the value, you will get, so this is nothing but 1 minus y minus 1, 1 gets cancelled, so you will get dx by dt as minus y, right? So similarly I have to find out what is dy by dt. So dy by dt is equal to dy by dt from the given equation. Dy by dt is nothing but x square minus y square, but x is nothing but x plus 1 and y is nothing but y plus 1. Substitute those values here, you will get x plus 1 whole square minus y plus 1 whole square. If you solve this, you will get x square minus y square plus 2 into x minus y, right? So now if you compare these two equations, here I don't have non-linear term, right? So but here I have non-linear terms. In order to proceed further, what I supposed to do is I should remove the non-linear term in a given equation. That means if I remove the non-linear term here, I will get dy by dt is equal to 2 into x minus y. So now we can linearize these two equations. That is nothing but dx by dt is equal to minus y, which is equal to 0. So this is nothing but y is equal to 0. We are finding new critical points. For that, the non-linear equation is reducing to linear equations. Okay. So the next one is dy by dt is equal to 2 into x minus y. This is equal to 0. I know the value of y. Just substitute it here. You will get 2x is equal to 0. This is nothing but x is equal to 0. So now 0, 0 is a critical point of, this is linearized system, right? So for the linearized system, 0, 0 is the critical point. Whereas for the non-linearized system, we got two critical points, that is 1, 1 and minus 1, 1. So now what we have to do is, we have 2 points now, that is x comma y is equal to 0, 0 and small x comma y is equal to 1, 1. These two equations are nothing but, I will call this as p of x, q of x comma y, and this as p of x comma y. Initially this is my f of x comma y, this is my g of x comma y, right? Now I am considering p of x comma y, that is nothing but minus y, and q of x comma y is nothing but 2 into x minus y. In order to find the eigenvalues for this autonomous system, I have to find out dou p by dou x. Dou p by dou x is 0 here. Dou p by dou y is minus 1. Dou q by dou x is 2 and dou q by dou y is minus 2, right? So now the matrix A is equal to, from this I will form the 2 cross 2 matrix. So if I write the position, this is dou p by dou x, this is dou p by dou y, this is dou q by dou x, this is dou q by dou y. Substitute the values here, you will get 0, minus 1, 2, minus 2. So now in order to find the eigenvalues, I should write a characteristic polynomial, right? That means determinant of a minus lambda I is equal to 0. Now this is my fundamental matrix. You can call this as a fundamental matrix now. So from this I can write minus lambda minus 1, 2, minus 2 minus lambda. This is equal to 0. So if you solve this, you will get plus 2 is equal to 0. This is nothing but 2 lambda plus lambda square plus 2 is equal to 0. So this is nothing but a quadratic equation. If you solve this, you will get lambda is equal to minus 1 plus or minus I. So that means lambda 1 is minus 1 plus I and lambda 2 is minus I minus 1 or minus 1 minus I. Okay, so now as we have observed in the previous session, eigenvalues are imaginary So critical points are stable and it is spiral. So this is in the case of 1 comma 1. We have to follow the same procedure for minus 1 comma 1. That means now x naught comma y naught is minus 1 comma 1. So your capital X will be equal to x minus x naught. I can write this as x is equal to x minus y. Similarly, y is equal to y plus 1. So dx by dt will be same and dy by dt will be x square minus y square minus 2 into x plus y. Again you will remove the non-linear terms. So your dy by dt will be minus 2 into x plus y. Okay. So again you have to find out p of x comma y is minus 1 and minus y, and q of x comma y is nothing but minus 2 into x plus y. So form a matrix from this. I will write the matrix directly. So you will get 0 minus 1 minus 2 minus 2. So mod a minus lambda I, or determinant a minus lambda is equal to 0. This implies determinant of minus lambda minus 1 minus 2 minus lambda is equal to 0. If you solve this, you will get minus lambda into minus 2 minus lambda. Minus 2 is equal to 0. So you will get lambda is equal to minus 1 plus or minus root 3. Solve this, you will get this value. Okay. So this means the critical points are real and distinct, right? So real and distinct means the critical points are saddle. So this is how we will solve the non-linear system of equation, and this is how you can find out the nature of the critical points, okay, and stability of the critical points. The next simple topic is limit cycle, periodic solution, and bifurcation of plane autonomous system. So we have very simple definition for these three, which is not so important as of now. Okay, for your reference I'm just giving the definition. Limit cycle means it is defined as an isolated point. The isolated point is nothing but limit cycle. If I consider a closed trajectory, this is my closed trajectory. Okay. So if this is my limit point, what happens is as t tends to infinity, this path approaches to your closed trajectory. So as t tends to 0, if the path approaches to closed trajectory, then that point is nothing but limit point or limit cycle. Even if I consider this as my limit point, at certain time this path approaches to your closed trajectory. You will get something like this. So this type of path is nothing but, or this type of cycle is nothing but a limit cycle. So periodic solution means if we convert, let us consider this is my equation. If I convert this equation to polar coordinate, I will write x is equal to r cos theta, y is equal to r sin theta, right? If you solve the given system of equation in this form, you will get a solution as a periodic solution. Converting a Cartesian problem to a polar coordinate and finding the solution is nothing but a periodic solution. Okay, bifurcation of plane autonomous system means here what we will do is we will consider autonomous equation, say 4z plus z square plus c. This is my equation. Okay, if c is equal to 0 and if I consider this as my f naught of z, if you plot a graph to this, your domain will be in this way. So my interval is varying from -2 to 2. Okay, if you plot a graph for this, you will get something like from -2 to 2, the values varies. If c is equal to 1, your equation will become 4z plus z square plus 1. In this case, your point will be from, so this will be your points. If you plot a graph, the line will crosses at this point. Graphically I am speaking. Okay. Similarly, if c is equal to 2, you will get 4z plus z square plus 2. So the point become even more closer. This will go a bit far. Similarly, as you increase c, at some point what will happen is in this part of your interval, the points vanishes and you will get only one point on your RHS part, like this. So initially when c is equal to 0, your points are from here to here. Okay, if c is equal to 1, the point will be somewhere here and this will come closer. C is equal to 2, this will come even more closer and these points will be at some more distance. When c is equal to 3, it will go somewhere here and these 2 points vanishes. So if you plot a graph, you will get like this. And this will increasing. So you can observe as you increase the constant value, one part of the graph vanishes and this will become increasing, right? So this type of equation or this type of system of equation is called as bifurcation of plane autonomous system. So initially you will get a solution at your face plane region. After that the solution vanishes. Okay. Now the last topic in this part is Lyapunov's direct method. So we use this method in order to solve the nonlinear autonomous equation. Nonlinear autonomous system of equation. So the definition says that if I consider a nonlinear autonomous system, say dx by dt is equal to p of x comma y and dy by dt is equal to q of x comma y. I will define e of x comma y. which is a continuous first order partial derivatives okay, at all the points x comma y in a domain D containing the origin also. So you will be having 0 comma 0 also. I can say E satisfies or E verifies Lyapunov method if E of 0 comma 0 is equal to 0 at critical point and dE by dt should be less than 0 for all x square belongs to R square. Third point is E of x comma y should be greater than 0 for all x comma y which is not equal to 0 comma 0. For x comma y 0 comma 0 it should satisfy this condition, right? For that's why if E of x comma y is greater than 0 means your x and y should not be equal to 0 comma 0. And the last point is E comma dou E by dou x comma dou E by dou y should be continuous in your R2. Okay, that means in your two-dimensional space. So if these four conditions are true, then you can call that E verifies the Lyapunov's function, or E is said to be Lyapunov's function. Okay. So now using this concept, let us solve one problem. This is the problem. Okay.